and welcome to the webinar called Discover Tacton Automation for PTC Creo. Today, I'm going to walk you through our latest CAD integration for PTC Creo. My name is Matthias Storm, and I'm the product manager at Tacton for our design automation or CAD integration solutions. Okay, so let's start with the agenda. We're going to go through the tool that we call Studio, and this is where we create our Tacton configuration models. We also do the CAD mappings, connecting Tacton with CAD. We set up constraints and also data to drive your products. And we need a user interface with the fields for the end user so that they can run the configuration model. We will also go through the tool called Engineer. This is where you configure your model inside Creo, and based on the results of your configuration, you can update your CAD model, the geometry, the 2D drawings, and once that is done and you're finished with your configuration, you would typically export the result to the necessary CAD formats that you have chosen. Tacton Design Automation for PTC Creo. Tacton Design Automation has been around since 2006, where we started with SolidWorks as an integration. And since then, we also integrated to Inventor since a couple of years ago, and now the latest is Creo that we released in the end of 2017. And we have already done a couple of releases since then. And we are a PTC developer partner in the Partner Advantage program. This is the tool that we're going to go through today. As you see, Creo is to the left, and then we have Tacton Design Automation Studio to the right, which is docked into the Creo window. This is where you create your design tree based on components, a component structure, and typically that will be very similar to your CAD assembly, and then you would create the connection between those two components. On the components, we also have something called attributes, typically the parameters of your parts and assemblies. And each component also has constraints and function to drive the model in a correct way. In the table tab, you can create your data, tables and variants can in the CAD assembly can do so that you can replace components with family tables and interchange assemblies. And then finally we have the user interface tab where we create an application and different steps, if you like, and groups, and within the groups we have fields, which is the question to the end user. So this is the mapping tool. This is where you create the connection between the CAD model and the Tacton model, and you can show the dimensions in Creo, and that lets you point and click on the dimensions to create the connection. So we have an easy point and click functionality, but we also have a filter list that filters or shows all the correct objects for this specific mapped component. I will go through this as well during the demo. We also have, of course, possibility to connect your drawings to the Tacton model. Since you're updating geometry, you need to control the drawings in terms of scale, view position, dimension position, etc., layers, and so on. So anything that you would typically have to do manually, you can now automate with Tacton Design Automation. And finally, once you're done with your configuration model and all the connections, then you can run the model. Either you have the separate tool called Engineer. This is the end user tool for, well, the engineers inside CAD that you can run the model. But we also have in the studio environment, the admin tool, we also have a runtime where you can test the model. So I will actually show you the runtime, but that is very similar to the engineer tool. As you see here, we have different GUI types. It's text boxes, sliders, GUI or image buttons, and so on. And these are standard GUI types that you can choose from. So let's head into Creo. And this is the model that we're going to automate. Very simple model, just so I can be able to finish in time actually. But we have a box with a hole, and we do have a cylinder that should fit into the hole. So 2 parts in one assembly, and as I showed you in the screenshots, to the right we have Studio, which is docked to the Creo application, so it follows. And we're trying also to use the same look and feel of Creo with the same icons, names, etc., so that you will feel familiar with this environment as well. To get a jump start, I will use the wizard tool called Create New Model from CAD. So if I have an empty model, I can push that button, and that will load your CAD model into Tacton Design Automation Studio. It does a little bit more than that. So right from the start, it took the assembly structure. We have the top component that is mapped to the box cylinder tutorial assembly. You see that the icons indicates what they are connected to. It created a box that is connected to the box part. Within the box, it created actually already some attributes. So what it did was, first it created the complete assembly structure in Tacton, connected those, and also collected all the named objects, like named features and named parameters or dimensions, and created attributes and mapped those as well. So we have, if I put on the filters here in, I'll just put on all of them in Creo. So for the box, we have a body and a whole feature, and those are named, and since that they are also mapped and connected. We have a width, depth, and height dimension, and also a diameter for the hole. And the domain is the initial value times 2, so it can range from 100 to 200. But these can of course be changed manually afterwards. For the cylinder, we had a body, feature, and then two dimensions. But we also have some constraints. So it actually found that we have the 2 of the same over the model. So the diameter is in 2 places. It's both in box and cylinder with the exact same name, and the same for height. It assumed that those should be equal and created these constraints, saying that all diameter throughout the model should be equal to each other. So it's 1 constraint and put all of them equal. In this case, it's only 2, but it could be 100, and still it only requires 1 attribute to control them. To make it easier to follow and maintain, I will copy and paste that, cut and paste that into the top assembly instead. So I will store all these kind of constraints in the top component. Okay, so let's do some cleaning. So now I will make this a little bit wider. I select the box and I go into Creo mapping editor. And this is where you would do the manual connections. So we see that we already have the box component connected, and we have the different dimensions. And this is the drop down that I talked about. Here you have all the dimensions. So you have actually 4 named one and 2 unnamed, and it only created those that are named. You could also, if you activate this and double click, you can point and click to the different dimensions to map them. Now they're all mapped, so we couldn't map them again. Okay, so here we have the features that is connected. We'll keep the whole to control the suppression state of the whole, the feature state. But we will remove the body, so the body should not be suppressed. Okay, and then we can actually remove that attribute as well. If we go to the cylinder, I will start by creating an attribute called Q2Y, and I will put the domain Boolean. Boolean means either yes or no. So the quantity is actually a special attribute that will control the quantity of this component. And this will automatically control the suppression state as well. So now if we go into the mapping editor for the cylinder, we see that the component is mapped. We see that the two dimensions are mapped, and we see the value is actually the attribute. So in this case, since it's automatically generated, it has the same name. You can also create connection to parameters, map keys, and features. Since we now have the quantity to control the suppression state of the whole part, we don't need to control it on the only feature in this part. So we'll remove that one as well. And then also remove the attributes controlling that. So now we also see that the quantity indicates that it's connected to the suppression of the component. We also have a debugger. So here you can see if there's something wrong, you can search or you can add comments. So we actually have two errors here, and this is because we removed the attributes. So if I double click, that takes me to the user interface. And we had some fields pointing to the attributes that I removed. So I also need to remove those fields. Those two, so now we should be fine. The wizard also created two steps, and the first one is actually not necessary, it's empty, so we will delete that as well. Okay, so we have done a quick cleanup, and we can try to run the model now. So the first thing it did was to unsuppress the hole and also the cylinder. And this is the user interface here that you see to the left. So here you have the different fields that was created for us. We can turn on the hole, and we can change, for example, the width to 200, and that updates the width. We can change the diameter of the hole to 180, and that updates. But we see also that it now destroys the geometry. So this is something that we need to fix. Okay, so let's go back, and we stop that and try to fix that problem. The problem is that the diameter should not be larger than the width or the depth of the model. So we will create two attributes. We will say that the depth, so here is the constraints, and we have the model objects. So this is what you can do as you type. So I typed in the depth attributes, and I would say that that should be larger or equal to the diameter plus 10, so plus 10 millimeters. Okay, and I will create another constraint saying that I can either click in the model objects, or I can type, and if it's only one, I can tab to automatically complete that sentence. Sorry, it should have been the width. The width has to be larger or equal to the diameter plus 10. So now that we have the width and depth, that should be larger than the diameter. We also want to control so that the hole suppresses also the cylinder in the same time. And that should be done at the top component. Start by creating a new constraint group. I will call that general constraints. And now I have something called components. So this is subcomponents to the one I'm writing on. So I can click on the box component, and I will grab the whole quantity attribute. And I will put that equal to the component cylinder quantity. So that means those quantities should be equal. Now we can run the model again, and we see that the cylinder is back, and if we turn off the hole, both of them are suppressed. We can change, let's say we change the diameter of the hole. That also changes the diameter of the cylinder, and also updated the width and the depth automatically so that it 10 millimeters larger than the diameter. Let's say we change the width to 200, that is still valid, but we want to change the depth, and we want the depth to be 120. And you might see that it turned orange. This means that this is valid, but it's conflicting with other values that are entered. So if I still select that, I will have a conflict with previous options, and it suggests that I should change the diameter to 90. So I can either cancel this or accept the change. So if I accept, it will change the diameter and the depth at once. So that's how easy you can create a configuration model. I will stop this now, and I will close down, and I will open the one that I showed you in the screenshots, our conveyor model. And I can open the TCX as well, connected to this model. So here we see the components of the conveyor, and we have a couple of more attributes and a lot of constraints as well. I actually see that we have an error here, so I will just, before I run it, I'll just fix that so we can actually delete that constraints. Yeah. So let's run the model, and we see that it updated right away. We have a standard fence instead of the speed fence that was initially in the model. Make this a little bit larger and make it like that. Okay, so here we have a part number. Let's enter one. Let's see. And I can enter a description as well. These are actually connected to the assembly parameters. So we see that we have the description and part number, and we have the values that I just entered. So these can be used in many ways. Perhaps, for example, you can use it in drawings to have texts in text box on the drawing. You can use this as input to what the file name should be once you export the results, and many more things as well. Let's change the length. So here we have the slider. I can just drag, and it updates all the components straight away. I can also type, for example, 1,500, 1.5 meter. And when it comes above a certain length, we have some constraints saying that then you need the middle support to be able to load the pressure. We can change the width as well. And down here we have the different, if you want a fence, speed fence or no fence. So let's try the speed fence. But you also see that some of the rollers turned orange. And it's the same that we have previously. So I can still select the wide roller, but then I need to change to no fence. So accept that, it updates the rollers and turn off the fences. What you would do when you're finished with the configuration is to export. And previously in tools option, I have specified which file formats should be exported. So this is already predefined in the options. So if I select yes or accept this, I have a summary of what will be exported and to where. And I can copy that path, and I will start the export. And we see that the files have been exported now, so I can open the 3D PDF. So this is one type of export that you can do with the Export Manager.